Okay, so here's a video I want you to work through and complete at the same time as I am to help prepare you for your Chapter 2 exam. With this worksheet or with this practice sheet, I highly recommend that you try out the problems on your own and then go back and check with each of my answers to see if you did it correctly. Or if you get stuck, you can start to play the first part of the problem and see what the first step is, and then pause the video and try to do it yourself. Otherwise, if you just sit here and just copy my notes and everything and you don't really try to think for yourself about how to do it, you won't really gain much from this video. So please make sure that you are considering that, okay? So the first one is a little review on diamond problems. So for diamond problems, if we have a diamond like so, the general rule has been, man, I am not drawing good this morning. There we go. Okay, so the general rule has been that if you have some number x and some number y, we multiply to the top. So I'm going to write multiply. So we get x times y. And then for the bottom, we add. So it's going to be x plus y. Okay, so these are a little bit tricky. Let me draw you just a quick little simple example here before I go to the trickier ones. So if we have this diamond here, and let's say that our numbers on the left we have, let's do -7, and then let's do a 3. So to get the top number, we need to multiply. So -7 times 3 is -21. And then for the bottom, we need to add. So -7 plus 3 is -4. So -4. So that would be a complete diamond problem. Now, for number 1 here, we have a few different things. So right here, we have the 6. And we know that the 6 is going to be added to something to get -2. So we can call that an x for now. And for adding, you can always set it up like x plus 6 needs to equal -2. So then you can just solve it like an equation. So if you draw a line down the equal sign, I'm going to move this away real quick. Let's see here. Just make it a little bit smaller. There we go. So here I can subtract 6 from both sides. Okay. If I cross that out, I get x equals -8. So let me pull up my Desmos calculator just so we can confirm that that is correct. So if we're trying to find the x here, and if I say that that x is a -8, I want to make sure that if I add these two, I get -2. So I'm going to try -8 plus 6 does equal -2. So I know that this is correct. So I can leave the -8 there. And now I have to multiply to get the top number. So I needed to find this number before I could multiply because I don't know what this one is, right? So I have to do -8 times 6. I'm going to get -48. Okay. So now we can do the same thing over here. However, this time this x that we're trying to find, I multiply x times -3 to get 15. So my equation will look like -3 times x equals 15. We can do the exact same thing. This is a one-step equation. In order to get the x by itself, we need to divide both sides by -3, just like that. These two cancel out. -3 divided by -3 is just a 1. So we end up with x equals 15 divided by -3 is -5. Okay, so now here I can write that this is -5. And then you can double check again. -5 times -3 is indeed 15. So to go up here, you need to make sure that this multiplication is true. And it is. So -5 times -3 is positive 15. And now to get down below, we have to add. So -5 plus -3, that's the same thing as saying negative 5 minus 3. And if you didn't catch that, you could always write negative 5 plus parentheses negative 3, and you'll still get negative 8. Negative 5 minus 3 is negative 8. Okay? So that would be the completed diamond for that problem. And again, please make sure that you are pausing throughout the video because I am going to go through it pretty quickly. Alrighty, so number 2. To bake 15 of his favorite cakes, let me get a different color here. To bake 15 of his favorite cakes, Mr. Willis needs 390 grams of sugar. How many grams of sugar would he need to bake 6 cakes? Set up a proportion. So a proportion is 2 fractions that are equal to each other, or 2 ratios that are equal to each other. Sorry, Marley's waking up, so she's walking around. Okay, so 15 cakes, and you can always like write cakes up here. 15 cakes need 390 grams of sugar. I use just G for grams. So if I know 15 cakes is 390 grams of sugar, then, and I know that he wants to bake only 6 cakes instead of all 15, I need to put the 6 on top where the other cakes are for the 15. And then we don't know how many grams of sugar those cakes need if I only need 6 of the cakes. So here what you can do is cross multiply. So we have 390 times 6, if you use your calculator, times 6 is 2,340 is equal to 15 times x is 15x. So I'm just going to rewrite that over here. 2,340 equals 15x. We're just solving. It's a one-step equation. So here, in order to undo this multiplication, I need to divide by 15 on both sides. So let's do 2,340 divided by 15 is 156. So this answer, so these 15s here will cancel out just to equal 1. 15 divided by 15 is 1. So I have 156 equals 1x, or 156 equals x. And that is 156 grams of sugar. Okay, so that would be my final answer. That's how many grams of sugar I need for 6 cakes at that ratio. Okay. Here we are. So now we have to find the perimeter. So in order to find the perimeter for this problem, we have to remember how to find area. So here I have this side length is 3, and I know that the area inside is 15. So I have to figure out, okay, 3 times what, I'm just going to use x here, equals 15, because area would be 3 times this top length here. So if I were to divide both sides by the 3 to get the x by itself, I'm going to get x equals 5. Now let's see if this makes sense. If this number up here was 5, then that would mean that my area is 3 times 5, which is 15. That is true. Okay, so now I know that side length, because my goal here is to find the perimeter. The perimeter is adding up all the outsides. I don't have all the outsides yet, so I need to figure that out. If this side length up top is 5, then this one right across from it is also 5, because it's a rectangle, so the opposite sides are congruent. Okay, now here for this 3, the same thing goes. So for this 3 here, if that's 3, then this over here is 3. And so now we can find this box inside right here. If we just do 8 times 3, that will tell me the area. So then this would be 24. Now we don't necessarily need that for this case because we're trying to find perimeter, but it's still good for you to know what would end up as the area for that box. And so here's another part, is that if this up here is 8, then this side down here is also 8. So now the only sides we need to find are the purple sides, so right here and right here. Now I know that the area of this rectangle here is 56. So that tells me that 8 times some number x gets me the area of 56. Okay? So if I divide both sides by 8 to get the x by itself, then I'm going to get x equals 7. So we can double check that to make sure that if that length is 7, I still get this area of 56. If you did 8 times 7 in your calculator, you should get 56. So we know that we're good there. And if you really wanted to now, you can tell me that this would be 7, so then this area in here would be 35. But here we're asked to find the perimeter. So perimeter means we add all the sides on the outside. So here I have, I'm going to kind of color code it. Let's do this. So I know I have 2 5s, 5 and 5. Okay, so 5 plus 5. And then I know I have 2 8s, 8 and 8. So plus 8 plus 8. And then I know I have 2 3s. Okay, 1, 2, 3. So plus 3 plus 3. And then I have also 2 7s. So I have 7 plus 7. This will be my perimeter. Okay? So try to add that together. What I'm going to do over here is just add like 5 plus 5 is 10, plus 16, plus 6, plus 14. So I just combined all of those. So your perimeter you should get for this problem is 46 units. They don't tell us if it's feet, inches, or anything. So if you wanted to write units, go for it. Remember, for perimeter, we do not write units squared. It's only units because it's not area. Okay, so number 4, we are going to combine like terms. Excuse me, big yawn. If it is not possible to simplify, please explain why. So let's focus on part A. The first thing we have to do here is distribute that negative. So that negative needs to be distributed into the parentheses. So that will leave me with negative times 2x squared is a negative 2x squared. Negative times positive x is a negative x. Okay, so then I have 5x squared plus 6x plus 3. So now I got to start to combine like terms. So I like to color code, as you know. 5x squared minus 2x squared are like terms, x squareds. So 5x squared minus 2x squared will be 3x squared. 5 minus 2. And then I see that I have 6x minus x. Okay, so 6x minus x will go next, and that will be a positive 5x. Don't forget the sign there. Okay, you have to tell me if it's positive or negative. And then this 3 here is just all by itself. Okay, so there's nothing to combine it with, so we're just going to write plus 3 down below. And this is our final answer. 3x squared plus 5x plus 3. Okay. So now here's part B. I'm going to start trying to look for some like terms. So first I'm going to start with just the lowest number in the alphabet, but the highest exponent. So my first one will be x squared. There's no other x squared terms. And then the next one is going to be the x. And there's no other x terms, so I'm just going to write that one down, plus x. And then now it's going to be my y. Oh, no, my y squared. The highest exponent goes first. So y squared. And then I have just the y, and there's nothing to combine that one with either. And then I have the 3 right here. And there's nothing to combine that number with either. So here I reordered it to be in standard form, but in this one there were no like terms. So I could not combine any like terms because there were none. There were no like terms there. So unless it says to reorder it, you don't always have to do that, but I recommend you always trying to do that and then just explain that there are no like terms. Okay, so this one, my lowest exponent is a. So 7a minus 4a, don't forget about that minus sign. 7a minus 4a is 3a. Okay. 2b minus 3b. If you struggle with that, just do in the calculator 2 minus 3. You should get a negative 1. So you can either write it as negative 1b or just negative b. It's the same thing. And then we have the 5 all by itself here. Okay, so the plus 5. And that would be your simplified expression. That would be your final answer there. Okay. So now let's go look at part D. Here I see that I have the variable p, and that comes before w in the alphabet. So p, negative 7p plus 4p. Again, use that calculator. Negative 7 plus 4. You can always use a calculator in my class. That's totally fine. So negative 7 plus 4 is negative 3. So we have negative 3p. And then I see an 8w, and we don't have any other w's, so we're just going to rewrite plus 8w here. And then here we have just the minus 1. So you guys notice I always save the numbers without the variables for last because you want to combine all your variables first. So this would be our final answer. That's us combining the possible like terms. We only had the p terms there. That was it. Okay, so now this one says, evaluate the expressions below for w equals 2 and z equals negative 7. So basically you plug in for w and z. Okay, so I'm going to go ahead and give these color. W I'm going to make green, and z I'm going to make negative 6. So what I would do first is color code. So the w will be the green, and I'm going to put it in this one as well. And then the z is going to be the orange, so the negative 6 is where I'll be plugging that in there. Okay, so I'm going to zoom in real carefully on this one here, real close. So here I have negative 2, and instead of the w, I want to put whatever my w is equal to, which in this case is a positive 2 from up above, plus 4 times whatever my z is. So z in this case is negative 6. So I'm going to plug in a negative 6 there. And then I just have the minus 1. Okay? So you guys can see how I just rewrote the exact same equation, but I plugged in the numbers I know are equal to w and z. So now if I simplify this, negative 2 times 2 is negative 4. Positive 4 times negative 6 is negative 24, and then minus 1. Now, you could just plug all this in. So negative 4 minus 24 minus 1, and we're going to get negative 29. You could also go step by step. So negative 4 minus 28 is negative 28, and then bring down the minus 1 again. You get negative 29. So that will be your answer there, is negative 29. Okay, and then for part B, so again we know that, so we have 3 times z, and we want z to be negative 6 here from up above, right? Negative 6. And then let's just bring down the plus 3, minus 4, and then whatever the green is, so the w, we want to plug in right here. The w is a positive 2. Negative 18, sorry, I should have stepped back. 3 times negative 6 is negative 18. Bring down the plus 3. Negative 4 times 2 is negative 8. So again, you could do negative 18 plus 3 minus 8. You should get negative 23. You could also break it down. Negative 18 plus 3 is negative 15 minus 8. Just bring that down. We get that is negative 23. And that's your answer for that problem. Okay. Again, make sure you're pausing throughout and trying these on your own first. All right, number 6 says to solve the following equation. Okay, so looking at this equation, the first thing we want to do when solving an equation is to draw a line down the equal sign, like so. we want to move all of the x terms over to one side. So it's totally up to you. Just once you decide what side to move it on, make sure you do that. I want to move my x's over to the left. So I see here my x term is a negative 2x. So to move that away from this side, I need to do the opposite of a negative, and I need to add 2x to both sides. Add 2x. Because here, negative 2x plus 2x is just 0. And then I moved it over to the left-hand side, so I kept it all nice and balanced. So here, 3x plus 2x is 5x. Bring down the plus 1. Equals, I bring down that positive 46. So now I have all my x terms off to the left, then I need to move all my constants over to the right side. So I need to, instead of adding this 1, right, I need to subtract that 1 from both sides so that I can move it away from my x. So I get one step closer to solving for x. So here, 1 minus 1 is just 0. So now all I have on the left-hand side is 5x is equal to 46 minus 1 is 45. Okay? So now my last step is to get that x completely by itself. Right here I have 5 times x. To undo that multiplication, I need to divide both sides by 5. Whenever we divide both sides by 5, 5 divided by 5 is just a 1. So I'm just left with 1x on the left side, and then 45 divided by 5 is equal to 9. So that is my solution. You could always plug it in to check your work. So I'm going to show you how I would do that. So to check your work, okay, rewrite the original equation, 3x plus 1 equals negative 2x plus 46. And we want to plug in our answer here in for x to see what we get. So if we plug in our answer for x, I'm going to draw a little line. So it's going to look like 3 times 9 plus 1 equals negative 2 times 9 plus 46. So we want to make sure that our equations are balanced here. Okay? So again, here the 9 is from our answer. So this is us checking our work to see if we got it right. 3 times 9 is 27 plus 1. Negative 2 times 9 is negative 18 plus 46. Well, 27 plus 1 is 28. And if you're looking at this one, you're like, crap, I can't do negative 18 plus 46 in my head. So use the calculator, negative 18 plus 46, and you will get 28. So then you ask yourself, is that true? Yes, it is true. 28 equals 28. So you know that your answer over here is indeed correct, as long as you plugged it in correctly, right? So that is really important. Alrighty, we're almost done. So number 7, Lance bought 11 books that all cost the same amount. His total bill was $88.66. How much did each book cost? And then it states, find the unit rate in dollars per books. So I need to put my dollars on top, the cost of the books on top, and how many books there are on the bottom in order to get my unit rate per one book. Because once I divide it, I can just put it over 1, so it would be per one book. So right now we know that he spent $88.86 on 11 books. So if they're all the same cost, I want to know how much each book cost. So if you just divide 88.86 divided by 11, you're going to get kind of an ugly answer. So we'll just say it's about $8.07, roughly, right? I really wish I would have caught that before I made this video. I would have changed this number to be something prettier here. So let's say, don't hate me for this, please, but let's say it was just 88. Let's do that, just to keep it a lot simpler for you. Let's say he just paid $88, that 86 cents was in tax. Okay, so let's say he just spent $88 on 11 books. If that's the case, if he spent $88 on 11 books, then what is his unit rate? Well, this would be, if we were to clear that out, 88 divided by 11. this tells me that he spent $8 per book. And I'll make sure to change this number in your PDF before I post it into your Google Classroom this morning. So here now I know that this is my unit rate. My unit rate is equal to $8 per book. So that means I can now tell you, like, what if I buy, so let's see here, if I have a little table here. So this would be my X, which are my books. And then my Y could be my dollars, right? How much I spend. So I know if I buy 11 books and I spend $88, then one book costs $8. So now you can kind of use that unit rate to say, okay, well, what about 2 books? Well, 2 times $8 would be $16. Okay, what about 7 books? Well, 7 times $8 is going to be $56. So now you can use a unit rate to determine the cost of all kinds of different quantities of books. So that's the point there. But for this answer, unit rate is $8 per book, or you could write it like this. This is the unit rate. Okay? Here's a bonus I wanted to do with you. So this one you will not see on your test, but it's still a really good problem to know. So it says here, Lily wants to save $230 for tickets to a rock concert. She has $50 now and will save $18 per week. So I see here that I have a concept of time. So I'm going to write down, let X equal the number of weeks. I need a variable here. And I'm going to say that Y equals, let Y equal the total cost. Because that's what we're trying to find. We're trying to figure out how she can add up to 230 degrees. Dollars, $230. So right now I could write an equation. Y equals, I know she's going to be earning $18 per week. So $18 every week, X. And I know that she already has $50 now. So I'm going to add a $50 piece to that because I know she's going to save this much each week, adding to what she already has. We actually know this Y here. The Y is really $230. So we know that she needs to get up to $230. So here we can leave this as a Y. And then down below, whenever we're asked to solve it to find out how long it'll take her to buy the tickets to the concert, instead of Y, we're going to put that she has to save $230. Okay? And then I'm just going to copy the rest of this here. Okay? So now we have an equation we can solve. We know she saves $18 per week. So first I'm just going to subtract out what she already has saved up because she doesn't need to make that $50. She already has $50 saved up. So that means this is going to tell me how much more she needs to save. She needs to save $230 minus 50. She still needs to save $180 in order to go to this concert. So she saves $18 per week. How many weeks will it take for her to save up to go to this concert? Well, if we divide 180 by 18, that kind of splits it up, right? It splits it up evenly. How many weeks will it take us to save up $180? Well, if we were to divide this by 18, we get 10. Okay? So here, our number of weeks, X, equals 10. 10 weeks. And that's our answer. And you could always plug it in. If you plug it in 18 times 10, and then plus, oh, not that. Let me put some parentheses. Yeah, there we go. And then plus 50, we're going to get $230. Okay? So there's the Chapter 2 prep. Please make sure that you finished all of your homework, all of your class notes, and are prepared to take the test this week. Reminder that all late work is due before the test. All right? Have a great day, everyone. Email me if you need help.